Sathyabama Institute of Science and Technology.
Good morning, everyone. This is Saraswathi, Assistant Professor from the Department of Computer Science and Engineering. Today, we are going to see a topic about queue data structure. A queue. A queue is nothing but a normal queue which we forms while getting a movie ticket. So, data structure has two types: a linear data structure and a non-linear data structure. A queue comes under the category of a linear data structure, and the queue uses an approach called first in first out approach. So in a movie ticket, the person who enters into the queue first will be getting a movie ticket first. Similarly, our queue data structure also uses the approach called first in first out approach. While inserting an element in a queue, the insertion takes place at the one end, which is called rear end. The deletion takes at the one end, which is called a front end. Application of queue in real time scenario. So the people on the escalator forms a queue, cashier line in a store forms a queue, a car wash line forms a queue, and a one-way exit also forms a queue. Similarly, our queue data structure also has a first in first out approach to store an element in a sequential order. These are some of the characteristics of queue data structure. In our queue, we can handle a multiple data at both the ends. In the front end, we can insert an element. At the back end, we can delete an element. Queue is a fast and flexible type of data structure. Data can be placed at the back of the queue, and the data can be removed only from the front of the queue. And we cannot able to delete a data which is present in the middle of the queue. Some of the types of queue data structure. There are four types of queue data structures: a simple queue, a circular queue, priority queue, and double-ended queue. First, we can see about the simple queue. A simple queue is a linear data structure which follows a first in first out approach. The queue is a collected element which placed in a sequential order. Queue is an approach which uses a first in first out approach. And when we add an element in a queue, all the elements will be added only at the back end. When we delete an element from the queue, the elements will be deleted only from the front end. And this is a circular queue. A circular queue is nothing about the front element will be linked with the back element. That is, we form a circular structure to connect a last element with the first element. And this is also called as a ring buffer. Main application of a circular queue is inserting a day in a queue within a week. This is called a priority queue. In a priority queue, all the nodes will be having some predefined priority. So when a node has to be deleted from a queue, the node with highest priority only will be getting deleted first from the queue, and insertion takes place in the order which it approaches the queue. And this is called a DQ. DQ is nothing but a double-ended queue. Here, insertion and deletion both occurs at both the ends. So insertion can also occur at the front end or back end. Similarly, deletion also can occur at the front end or back end. This is called as a double-ended queue. So these are the four types of queue in data structure, and these are some of the basic queue operations. So basically, we will insert an element in a queue, we will delete an element from a queue, and we can see what are the elements are there in a queue, and we can create a queue, or we can check whether our queue is empty or whether our queue is full. If you want to insert an element in a queue, first we need to check whether our queue is full or not. If a queue is full, we cannot able to accommodate a new element in the queue. So before deleting an element from a queue, first we need to check whether our queue is empty. So when our queue is empty, we cannot able to delete any item from a queue. So a queue can be implemented in two ways. The first method, a queue can be implemented using an array, which is nothing but a sequential allocation, where we will organize all the elements in a sequential order, and this array has a finite size. So fixed size, only a fixed number of elements can be inserted in a queue. So element beyond the size cannot be inserted in a queue if you are implementing a queue using array. And this next approach is called implementation. We can implement a queue using a linked list. This linked list can be used to overcome the disadvantages which we are having in an array. So a linked list is nothing but it has a infinite number of, we can have infinite number of element in a linked list. There is no limitation about the size of a linked list. So we can implement a linked list using, we can implement a queue using linked list if you want to store infinite number of elements. And these are some of the example for queue using array and queue using linked list. This array has a fixed number of size. Here our array has can accommodate only 10 elements. If you are trying to enter the 11th element, it is not possible in array because array is of fixed size. Whereas in a queue using linked list, we can add n number of infinite number of elements. If you want to add a new element, it can be possible in an array, in a linked list, if you are connecting the last element with the newly added element. So the only thing which we are going to do using a queue using linked list is we need to create a node and we need to connect the last node with the first node, newly created node. And these are some of the operations. We are going to see the operations about queue both using array as well as using linked list. So this is enqueue operation using array. So in array, as I said before, in array only we can able to store a fixed number of elements. So if you are going to store the element beyond its size, it is not possible in our array. So before entering, trying to insert an element in an array, first we need to check whether our queue is full or not. Because if the queue is full, we cannot able to accommodate the newly inserted element. So before adding element in an array, first we need to check whether our queue is full or not. If our queue is full, we need to display a overflow error message. If the queue is not full, we need to check whether the queue is empty or not. This is because if a queue is empty, we need to increment both the front variable as well as the rear variable. So the rear is nothing but the place where we are going to insert an element in a queue. So if a queue is empty, initially both the front and rear will be is equal to -1. So if you want to insert a first element in a queue, we need to increment both the front and rear variable. If our queue is neither full nor empty, in that case, in that scenario, only our rear part will be incremented. We won't disturb our front part because the elements are going to be inserted only at the rear end. So the rear value alone will be incremented. So in this diagram, this is a diagram which represents the queue before inserting an element. So here we have only 3 elements. A represents front, C represents rear, and we are trying to insert a 4th element called D. So if you want to insert a 4th element, our rear will be incremented to the next empty space. So in this scenario, our rear has been incremented to the next place, and we are inserting our D value, and now our rear is representing our D. So here rear end will be a element called D. So this is the algorithm. So here we can able to see all 3 choices. How our queue will be when our queue is full, how it looks, when a queue is empty, how it looks, and when a queue has some value, how it looks. So in the first scenario, a queue is full, we cannot able to store any values in a queue because we don't have any space. In a second scenario, our queue is empty, which represents our front and rear is equal to -1, then there is no value in a queue. And in the third scenario, our queue has some value as well as it has some empty space to accommodate a new value. So this is our algorithm. So here first we will be checking whether your queue is full by using this condition. We will be checking with the rear value. So when a rear is equal to max -1, which indicates that our queue is full, we cannot able to accommodate any new value. So we can check whether a queue is full by using a condition called rear is equal to max -1. If it is true, if the condition is true, then we will be displaying a error message, overflow error message. If our queue is not full, then we will be checking whether our queue is empty. This will be checked by using a condition rear is equal to -1. So if rear is equal to -1, which indicates that our queue is empty, both the front and rear is equal to -1. In that case, we need to increment both the front value as well as the rear value with 1. If our queue is neither empty nor fill, in that scenario, we won't disturb the front variable, only the rear variable will be incremented with 1. So here our rear variable is incremented with 1, and in that particular place, we are inserted the new value. Newly inserted value has been placed in that particular place. Next, we will be deleting, looking how to delete operation by deleting an element by using array. So first here in this scenario, when we are deleting an element in an array, we won't check whether queue is full or not. We will be checking whether a queue is empty, because when a queue is empty, we cannot able to delete an element from a queue. So for that reason, we will be checking whether our queue is empty. If our queue is empty, it will be displaying a error message, underflow error message. If our queue is not empty, in that place the value which is in the front position will be removed from the queue. So in that case we need to increment the front value. We won't disturb the rear value, we will be incrementing our front value. So in this diagram, the first diagram shows the value queue with 4 values, and in the second diagram, after deleting, our front has been incremented. We didn't disturb the rear position. Only our front value has been incremented with 1, which indicates the first element, which is A, has been deleted from the queue. So this is called a dequeue operation using array. Now we can see how to implement a queue using linked list. So this is our algorithm. So algorithm for dequeuing. So here our empty queue has a front and rear value with -1, and this is a queue where we have some space. So if you want to delete a value, our front will be incremented, we won't disturb our rear part. So here when our queue is not empty, then we will be incrementing a front position and we will delete the first item from the queue. So this is our queue implementation using linked list. In linked list also we can able to delete an item, we can able to insert a newly inserted item can be connected with the existing linked list. So these are the steps in our while we are implementing queue in a linked list. We don't want to check whether our queue is full, because only array has a fixed number of elements, whereas a linked list we can add infinite number of elements. So here we are not supposed to check whether our queue is full or not, but we need to check whether our queue is empty. This is because if a queue is empty, both the front value and the rear value will be assigned as null value. So when a queue is empty, we need to create one new node has to be created, and that particular node has to be assigned with a front and rear value. So here first we need to create a node, and that particular node's next value will be null. First we will initialize it with null, and when a queue is not empty, we will set our front as well as rear to the newly created node. And if a queue is not empty, in that scenario our rear position will be changed to a newly created node. So existing linked list last node will be connected with the newly created node, and we will change the position of the rear with the newly created node. So this is the algorithm for inserting an element in a queue using linked list. So here first we will be creating a first step is to create a newly created node. So newly created node has been we have created a new node with a name called new node, and the new node's next value has been initialized with a null value. And in the second step we are checking whether our front is equal to null, which indicates whether our queue is an empty queue or not. Because if a queue is an empty queue, in that case we need to assign both front value as well as the rear value to a newly created node. If our queue is not empty, the else part, only the rear position has been changed to the new node, and we are just displayed the message insertion is successful. And this is a dequeue operation using a linked list. So dequeue is nothing but deleting a node from a linked list. So when we are going to delete a node from a linked list, first we need to check whether a queue is empty. Because if a queue is empty, we cannot delete any item from a linked list. So if a queue is empty, both our front and rear will be initialized with a null value. So by checking that condition, we can come to a conclusion whether our queue is empty or we have some values in a queue. So if our queue is empty, we will be displaying a message called queue is empty, we cannot able to delete any item. And if a queue is not empty, in that scenario, we will be changing our front position. So we will be changing our front position, we won't disturb our rear part, we will be using, we will be incrementing our front position to the next node, and we will free the existing front value. So this is the algorithm for dequeuing element in a queue using a linked list. So here in the first step, we are checking whether front is equal to null, which indicates we are checking whether a queue is equal to empty, whether our queue is empty. If our queue is empty, we will be displaying a message called queue is empty. If our queue is not empty, in that scenario, our front value has been incremented to the next node, which indicates front is equal to front of next. And we will be freeing the temp value. A temp is nothing but the value where we will store the previous front value. So in this diagram, this is our first diagram before deleting a node from a linked list. So here we have 25, 50 and 75. In this linked list, we are going to delete our a single node, which is nothing but a head node has to be deleted. So here our front will be, that is head will be moving to the, from 25 it will be moving to the 50. So it has been moved to the 50, and in the temporary variable we will be storing node 1's detail, and that particular detail will be free. We will delete that particular node by using a free function. The next we are going to see about some of the applications of queue data structure. The task scheduling, resource allocation, batch processing, printer queue, event handling, message buffering are some of the queue data structure we will be seeing in our day-to-day life. So with this we can end up this session, and I will be seeing you in my next video. Thank you.